Good evening, everyone. Am I audible? You can just put a message. Okay, fine. So those who all of you who are present here, welcome to week 8 of Data Science for Engineers course. So this week we had looked at clustering algorithms as well as k-nearest neighbors algorithms in your lecture classes. So based on that, you given assignment questions. So today I'll be discussing with you the assignment questions which were given in the previous course of July 2023 and Jan 2023. So these questions might be similar to what have been given to you now. Okay, so this will help you in solving the present questions. So we'll move on to the first question. The first one, so you can answer in the chat window for the answers. So
Madam, your screen is not visible.
okay, just
No, it is
a
not visible.
moment.
Slide is not visible.
Yes. Is it visible now?
Yes, madam. Yes, madam.
Okay. So everyone, this is the first question. Consider the data set usrs.csv, and using this data set we have to answer questions 1 to 4 based on the information given below. So this is the data set which has states, murder, assault, urban population and rape. Okay, so the state where the incident occurred, number of arrests for the murder per 1 lakh residents, and number of arrests for assault, percentage of urban population and rape arrests. Okay, then so the things we have to do on this data set is like set the columns states as the index of the data frame while reading the data. Okay, so we have this particular data frame. Whenever it is read, then there itself we have to set the index as states column, then set the random number generator to set seed of 1, 2, 3, and then you have to normalize the data using the scale function and build the k-means algorithm with the given conditions. All right, so these are the first things that you have to do. So people who are having RStudio with you can just move on to your RStudio and then you can start programming. Okay, and so I'll just move on to the RStudio right now. So first I'll be setting my working directory which was told in the lecture classes also. So you can use the setwd method. Just I will increase the screen font size. Okay, so I hope this is visible right now. So what I'll be doing is that this you can do every time also. Sometimes your working directory might be the same as you are having the file, then it's all right. So just I'll be setting the directory once more. So I'll be using the setwd command and I'll be putting the path where my files are present. Okay, so I'll be running this particular line, and this is used to remove the variables which are present, so that also I'll be doing. Then after that, what you have to do is, if these packages are not installed, like the caret and the class, if they are not installed, then you have to use install.packages and install.packages for class as well as caret. So I already have these packages installed in my system, so I won't be doing that once again. So next I'll be moving on to include this in my environment. So I'll be using library of caret and library of class. These two packages we had seen last classes itself. Okay, these were taken last classes itself. I hope you remember. So the first question is, according to the built model, the within cluster sum of squares for each cluster is, the order of the values in each option could be different. that is given. Okay, just I'll move on to the slideshow once again. So in that we'll be moving on to the steps in a short time. So yes, so after doing the basic operations, what you have to do is, according to the built model, you have to find the within cluster sum of squares for each cluster. Okay, options are also given. You might have already solved this one. If you have solved it, you can put the answers. Otherwise, just I'll be moving on to the RStudio. Here the first thing is you have to read the data, right? You have to read the data. So here what I'll be using is, I'll be doing read.csv. This is not required, read.csv, and I'll be doing a file.choose. This much is not required right now because we have already set the working directory, and if you directly give the file name, it can directly take that. But still, anyway, I have used it once, so we can have, if the file is saved in another location, then also you can have that file here. So for that I am using file.choose, and header equal to true I am putting, so that the header column or the first row is taken as the column names or feature names. And now I am putting like row.names equal to states, because what was given in our PowerPoint presentation, it's given like set the column states as index of the data frame while reading the data. So we have to set the column states. So because of that, I'll be putting row.names equal to states. Okay, so this does that. And just for a moment, I'll be showing you the data set. So this is the data set given. So states, murder, assault, urban population, and rape. And this particular column states has to be put like the index. So that's why we have specified as row.names equal to states. And this first row is taken as it's known as the header of that particular data set, right? So this particular header we are giving like it is equal to t. That means header is present. We'll be telling the read CSV function. So this is the data set that we'll be loading to the RStudio right now. So we are doing data equal to read.csv, file.choose, header equal to t, row.names equal to states. Okay, so I'll be running this line. So it is asking, so USRS. Okay, I'll be loading. So if I read the data, if you give view of data, or just if you click on this environment variable, so you can see that data is there. The states which were there as a separate column in the file that we had seen is now like the index. Okay, the Alabama, Alaska, these states are made as the index of the data frame. And the other things, the first row was taken as the header, so that's why it's given as the column names are present, and the rest of the entries are present. 4 total columns are there, and a total of 50 entries are present. All this can be read in this particular window. So we have read the data. So according to the slideshow, we have read the data and set the column states as index. Now we have to set the random number generator to set.seed123, and then normalize the data using scale function and build the k-means algorithm. So these are the steps to be done. So next what we'll be doing is that we have to scale the data. So I am putting a new data frame name df. Df means scaled version of the data frame data. Okay, so that the function used is scale. Okay, so scale of data I'll be doing now right now. So first when we can view the data, it is in this form, right? 13.2 like this, it is in this form. So if I click on df, now for the same indexes which are given, it's like in between certain values. Okay, it's scaled to the mean and the variance of that particular column. Okay, so we are scaling the data and we are storing it in df. Now we have to fix the how the randomization is done. So for that we are putting set.seed of 123. Okay, 123. So this I'll be doing now, and now we have to do a k-means clustering. Okay, k-means algorithm. So fit, we'll be putting k-means of df, which is the scale data. Centers equal to 4 was mentioned, and n start equal to 20. So before we go for this particular solving this particular question, I can show you what the different parameters are. I'll be using this particular post. Okay, so in this one you would have seen that you have mentioned how many centers, you have mentioned how many n start values are required. So what all these are, I'll be explaining now. So if you have given, so actually if you are giving this one, so if this particular thing means the data, a means the data, iter.max means the number of iterations, number of times the algorithm is run before the results are returned. Okay, and the next one which you should be careful of is the n start. Okay, that represents the number of data sets used to run the algorithm. So if for example if you are specifying that you want 3 clusters means your whole data you want it to be grouped to 3 different classes, that means it should be given, the number of clusters should be given as 3. Okay, so this is specified in the second argument which is to be given to the function k-means algorithm. Okay, and so the n start, if you give like 10, that it means that it extracts 3 sets of data 10 times, and for each of these item the algorithm is run up to the maximum number of iterations which is given. Okay, and after this only the cost function is evaluated so that the lowest is chosen as the result. So for our particular example, we have given the data k-means of df, centers equal to 4 we have given. Okay, so we are trying to make it to 4 clusters, and n start is given as 20. So it means that 20 times 20 times the 4 sets of data will be collected. Okay, so if you are not mentioning the iteration.max, it will be taking the default value. Okay, so based on these things I'll be doing fit of k-means given by df, centers equal to 4 and n start equal to 20, which was given in our question. Okay, so what all was given in the question, we have used the same thing. So I'll be running this particular line here. So the fit has been formed. Okay, and our first question was to find the within cluster sum of squares. So for this particular example here there are 4 clusters, it will be 4 clusters will be coming. All right, so one cluster will be formed. This is just a representation, we'll see the plot later. Okay, next cluster will be, if it's like this, and the third cluster and the fourth cluster is like this. Okay, so 4 clusters are present, and in these 4 clusters our question is right now to find the within cluster sum of squares. Okay, so it's like now we have these 4 clusters. Okay, these 4 clusters are present, and we have to find inside the sum of squares. All right, so for this, anyway, we have fit the model, k-means model, to this particular name fit. Okay, so fit, if you give dollar, it has many, this fit function, the fit name right now, it's a k-means model, clustering model. So this fit, if you give a particular parameter asking for within SS, that means within cluster sum of squares. Okay, so if you print fit dollar within SS, you will get the within cluster sum of squares. Okay, so I've got the answer, and it means it's similar to the one which is given in the first option. Okay, I hope you might have got this answer itself. If any doubts you are having, you can ask now in this question. Okay, I think I can move on with the next question. So I have put the code snippet here, just you have to read the data, and after that df is equal to scale of data, set seed, and then you have to fit the k-means algorithm to the name fit. Okay, then you can print the within SS values, and you'll get the particular answer which is given there. So the next question is, according to the built model, the size of each cluster is. So this means to find the number of elements which are present in a particular cluster. So you might be grouping a particular class in this. So the number of the observations present in a particular cluster is asked. Okay, so this also can be done with the same model name itself. So fit dollar size, if you give, then you can get the number of or size of each cluster. Okay, so within SS will give you the within cluster sum of squares. Fit dollar size will give you the size of each cluster. So it means that the first cluster is, so one of you have put the answer C, so that's true. So answer is C. So you can get 8, 13, 16 and 13. Okay, this is the cluster size. Then the third question is, between cluster sum of squares value is. So for that, the option, the function to use is fit dollar between SS. Okay, it's as easy as that. So if you print the between sum of squares of all the clusters, you'll be getting the value 139.5968. okay, so it's given in a range here right now. So in this one, the answer we are getting like 139.5968. okay, so you can put in the range of 100 to 200. okay, so we have finished the first 3 questions, and in this group one more question is remaining. The total sum of squares value of the built k-means model is. Okay, so to find the total sum of squares, we have TOTSS. okay, so for that, if you do, you'll be getting the answer as 196. okay, so that is also in the range 100 to 200. okay, so I hope these 4 questions are clear right now. okay, so first the data set was given. Just I'll briefly go through the first 4 questions. Data set was given. We were asked to set the column states as index of the data frame. Then we have to arrest the randomization so as to reproduce the same result next time. So we have put set.seed equal to 123, seed of 123, and then we have normalized using the scale function and build the k-means algorithm. Vaishali, these kind of questions won't be coming. Okay, the one which requires RStudio for you to be solving that won't be coming. You might be asked, so I hope you have gone through the lecture videos. So there you might be given, so how do you find this distance actually? You will be having, just a moment, okay, so in the lecture videos you might have found, so this is like data set which has 50 observations and all, and such kind of questions can't be done without using RStudio. Okay, so many observations are there, but the questions that you might be getting might be like, there might be 1, 2, 3 up to 10 observations might be there, and like you have seen in the lecture slide, there might be, I mean, the possibility of having two classes. Okay, so they might be giving, you can have the question like maybe a scatter plot can be given of two observations, and you might be finding it as you will be having two clusters. Okay, two clusters might be present, okay, in your data if you see, or maybe they'll be defining it as you have to do it in two clusters, like that maybe. So how have you started in the lecture videos? It's like randomly you will be selecting a point from these two clusters, right? So I think it was like in the first question it was like 1 comma 1 and 3 comma 3 in the lecture video, right? So what you have done with that, you have looked at each observations and found out the distance of each of that observations with the points which were selected, and you had given like distance 1, I mean distance 1 and distance 2, and wherever distance 1 was greater than distance 2 you have given like class 1. Okay, wherever distance 2 was greater you had given like class 2. Okay, and then you had taken a mean of the observations that had come as class 1, and or it was given like group 1. Okay, mean of points which are taken in group 1 and group 2 you had taken, and then you had found out the particular, I mean how many clusters should have been taken, or what is the value for the clusters, you have seen that. Okay, so you won't be getting questions like these in your exam. You'll only be getting how to calculate them, or find out the sum of squares of the values from the cluster, which from the cluster center that you have taken. Those all will be asked. Okay, so sum of squares, if you want, it's like the new point, new cluster point which you have selected, and the, so if the new cluster point that you have selected is this one, from this how much distance is there you can find out, right? You can just take the Euclidean distance between them and you can find the sum of squares. So it's like that questions only will come. Or all right, Vaishali? Okay, so we'll move on to this one. So so I was just telling you about all the 4 things. So we have normalized the data, and we had built the k-means algorithm with number of clusters as 4 and n start equal to 20. Then we have looked at within SS for getting within cluster sum of squares. Then we had seen fit dollar size for getting slice for each cluster, and then for getting the between cluster sum of squares we used between SS. Okay, between SS was used, and then for finding the total sum of squares we used total of TOT SS. Okay, so we'll move on to the next question. I hope there are no doubts. Okay, so those next question is like, which of the statement is incorrect about the KNN algorithm? So right now you can see that I've already given the answer. So answer is, incorrect one is KNN works only for binary classification problems. Okay, that is incorrect because KNN works for multi-label classification problems also. Okay, then the next one will be K-means clustering algorithm clusters the data points based on dependent and independent variables, eigenvalues, distance between the points and a cluster center, none of the above. K nearest neighbors, maybe you'll be asked to you'll be asked, like, maybe you'll be given the one example is like you can be given the elbow method calculation and you'll be asked to find out which is the appropriate number of k values. Like that questions can come because all the other things will require so much calculations, right? Okay, so k-means clustering classifies variables based on the distance between the points and a cluster center. Okay, then the method or metric which is not useful to determine the optimal number of clusters in unsupervised clustering algorithms is. You can give the answer for this one. Okay, yeah, one of you have put A. Any other answers? Okay, D, none of the above. I'm getting C, A. Okay, so actually what is a scatter plot? Do you remember? Okay, yeah, scatter plot was those who are giving scatter plot just so if for this particular option, if I am giving like so it's like if you have two variables, okay, so in the USRS there are like number of just I'll go to the R studio and the data is like there is murder, assault, urban population, rape, like that for the different states. Okay, so if you are having like finding the rates of like murder, number of murders, if you're finding, it's like you'll be getting like for each state. Okay, for each, like first one if it's Alabama, then Alaska, it might not be that much readable, but anyway, so for these different states, okay, you'll be putting 1 2 3 like that it will be doing. Okay, so this is the scatter plot, just as plotting of observations of x and y values, that is scatter plot. So can scatter plots will help you to determine? You can calculate, okay, but in cases if it's very much separated, okay, that is possible. Okay, in cases like where you have, so if you draw your plot like this and yeah, it will give, that's what I've told in the first slide actually. Okay, how can you go about giving the k value? It can give some idea, but it's not a perfect one because okay, if your data is separated like this, you can just from the scatter plot itself you can find how many clusters can be formed. For this particular example there can be 2 clusters, but when your data is like this, okay, and then you have some other observations like this, okay, sometimes your clusters will be overlapping, and from the scatter plot it's kind of like little difficult, okay, or you can't just that much say. Okay, sometimes if you are giving to a clustering algorithm, sometimes they might be forming clusters like this. This also is possible. Okay, so scatter plot alone will not give you, or it is not a useful metric to determine the optimal number of clusters. You are asked to find the optimal number, right? The number which will be giving the minimum misclassification, right? Or minimum, like everything in that particular cluster belongs to a particular class only. So optimal number is asked, right? So optimal number won't be given by a scatter plot. So the answer here right now is A. Elbow method, I think you have seen, right? For different values of k. So it's like if you have a data with x-axis with the varying amounts of k, and if like you are getting an example like k equal to 1, here 2, 3, and then the errors are like moving in this way only. There was a great distinction here, right? From k equal to 1 to 2, this was decreasing like this, and k equal to 2 to 3, that much decrease is not there. So you can say that optimal value of k to be used is k equal to 2. Okay, then dendrogram method, that's another method. I'll just use an example. Okay, that is also used to say how many clusters will be there. Okay, so it's a hierarchical clustering algorithm. Just I'll increase the size. Okay, so how it looks like is in this way. Okay, so dendra, you categorize the objects into an hierarchy. So here in this case we will be clustering also, and there will be a tree like structure also. Because of the tree like diagram only, it's known as a dendrogram. Okay, then the distance of split or merge, called the height, is shown on the y-axis of the dendrogram. So this is how a dendrogram looks like. Okay, then if you see this one, it looks like a tree only, right? It looks like a tree, and the height will represent the distance of split or merge. Then you can see first 4 or 6 are combined into one cluster, then followed by 1 and 2, then after that 5 was merged in same cluster. Okay, so how can you, so if you like make the cut like this, okay, if you make the demarcation like this, you will end up with only 2 clusters, right? If you look, there is only one cluster here and there is another cluster here, if you give the demarcation in this particular level. Okay, now if you bring it down so much, then you can have more number of clusters. That is the thing. So at the end, just for an example which was given in this particular page, you can see that if you, this is a cluster dendrogram. Okay, this is so many observations are there and the height is given. So if you are putting the height as this level, okay, just 4, if you are giving like in this particular level, if you are giving, then you can just see that main clustering is like 2 clustering is only there. Okay, if as long as you go down, you can find more and more clusters. Okay, so this is, so dendrogram also is like something which can be used to determine the optimal number of clusters in unsupervised clustering algorithms. Okay, so I hope that's clear. We'll move on to the next question. Okay, so and the next one is unsupervised learning algorithm which aims to partition n observations into k clusters, in which each observation belongs to the cluster with the nearest centroid is. You can give the answer. Okay, I've got B. Okay, yeah, that's true. So k-means algorithm identifies k number of centroids and then allocates every data point to the nearest cluster while keeping the centroids as small as possible. Okay, so answer is B. Now some practice questions I've included. I hope the present assignment also is similar to the one which I have discussed. So these practice questions are: the most commonly used distance metric to calculate the distance between center of each clusters and data points in k-means algorithm is. This I have already told in the lecture. You can tell me what is the answer for this one. Okay, C, that's true. Euclidean distance. Yes. The k-means clustering classifies variables based on I've got C, distance between. Yeah, everyone's having that answer. So distance between the points and a cluster center. Which of the following is not true about the KNN algorithm? Okay, explicit training and testing spaces are involved in implementing KNN. Scaling is important in distance based algorithms because. Okay, so Neil, non parametric is like. Okay, so the last classes we were looking at regression, which were parametric algorithms. Okay, I hope you remember that from last class, right? So non-parametrics is like they do not rely on assumptions that are drawn from the given probability distributions. Okay. So how have we found out in linear regression? We had formed like we have seen the data, we have seen how the data was distributed, right? And we have formed a set of equation. We have used an equation to fit the model, all right, in linear regression analysis. So that based on certain, it requires certain interval or ratio data. Then in case of non-parametric methods, they are typically used on data which are nominal or ordinal, meaning like they are categorical data. Okay, so here in this particular case, I think it was the previous question, just wait a moment. Yeah, so k-means algorithm, it doesn't rely on assumptions made on the data which is given. Okay, so it is like we will be looking at. Aishwarya, you have given answer A for this particular question, or okay, anyway, so in KNN algorithm, it's known as a non-parametric algorithm. You can go through the lecture slide also. So it's like it doesn't rely on assumptions that are based on the data. Okay, if it is a parametric algorithm, then it relies on the distribution of the data and the probabilities drawn from that particular data. Okay, so I've got an answer A. Actually, for this particular question, the answer was C. Okay. Okay. Neil, is that clear? Okay, yeah. Then have I come? Yeah. Scaling is important in distance based algorithms. Yeah. So for this one, answer is A. Variables with higher magnitude will influence the result more. Okay. So that's true. Okay. Any problems in this one for anyone? Okay, if not, I'll come to the next one. Which of the following is true with respect to k-means clustering? B. Okay, that's true. So it's like in k-means clustering, the distance between the clusters or different clusters should be maximized, and the distance in between each cluster should be minimized. Okay, so answer is B. Now I'll move on to R Studio. Okay, so in R Studio, so right now I have this data. Okay, so what I'll do here is like I'll take a new data set and we'll see the different things. Okay, so first I'll have a k-means clustering with respect to iris dataset, which have been the dataset that we have been seeing the past weeks. Okay, so about the assignments, these are all the assignments that were in the present week. Actually, I hope this is similar to the one that you have seen. Okay, so that's why I'm moving on to another dataset right now. So here you can see that k-means clustering using iris dataset. It's unsupervised, it's non-linear algorithm, and cluster data based on the similarity or similar groups. Okay, so for that I'll be loading the iris data. Okay, and structure to see the structure of the data set. So just I'll be clearing the environment first. Okay, so data I'll be loading once more. So iris data we have seen last class itself, so I'll be directly moving on to the structure of the data set. So the structure is right now sepal length numerical, sepal width numerical, petal length numerical, and petal width numerical. The species is a factor with levels setosa versicolor. Okay, so it's directly as a factor, we don't have to change anything. Okay, then for clustering I'll be using packages known as cluster R and cluster here. Okay, so if these are not present in the library right now, I will have to install it using install.packages, or like I said last class, just you can go to packages and search for them. All right, okay, search for the package and then you can install it. Okay, anyway, I already have these packages in my environment, so I'll be putting library of cluster R and cluster. Okay, then what I'll be doing is like, since this is a clustering algorithm and k-means clustering is unsupervised, I will be removing the species column from the original data set. Why? Because there should not be any label in an unsupervised algorithm, right? If it was supervised, we'll be using the species column as our target column. Okay, so here right now it's not supervised, so we are removing the target class, which is represented by the fifth column, right? So iris dataset first column and species is the fifth column, so I just put iris of -5. So that's why it is now without any label. Okay, so iris 1 I have put this one. So this particular data frame right now has only the 4 columns with sepal length, sepal width, petal length, and petal width. Now just to set the randomization, to arrest the randomization, you can say set.seed 240 I'm giving, so that you can reproduce the same result. Then kmeans.re, just I'm giving kmeans of iris 1, centers equal to 3 first I'll put, okay, centers equal to 3, n start equal to 20 itself I will give. So I have given the k-means model, and then if I do this one, you can see, I just increase this one. So here you can see that k-means clustering with 3 clusters of sizes 50, 62 and 38. So the total data set was 150 in number. It got clustered like this, okay. Then cluster means for sepal length for each of the clusters, okay, for sepal width everything is given, and we can also observe wherever the clustering had happened, okay. So 1 denotes cluster 1, okay. For the first observation it is clustered as in group 1, okay. Now within cluster sum of squares by the cluster, within cluster sum of squares. So in your exam also maybe you will be given like find, you will be given between sum of squares and total sum of squares, and you might be asked to find something else, okay. So that can also happen, okay. So just we now have found out for each observation how is the cluster that is there. Now just if I have a confusion matrix, okay, so because I have taken the cluster, this is how the clustering have been done, and the fifth column known as the species, which is there in the iris data frame, if I take like iris dollar species, I can get just the labeling of the data frame. So I'll be drawing a table. So if I use table of iris dollar species and kmeans.re dollar cluster, I will get a confusion matrix between them, which will help me to identify how it have been clustered, okay. So now here you can see that almost for all of setosa it has been clustered correctly, okay. Then for the next one, versicolor, okay, the clustering was not done perfectly, and for the other one also the clustering was not done perfectly, okay. So there are some misclustering which had happened. Now just we will plot the particular thing and see how it looks like. So I will be plotting of iris 1 sepal length and sepal width, and in that I'll be putting the, just wait a moment, okay. So you can see here this is just the plot, this is kind of a scatter plot which have been drawn, sepal length and sepal width, okay. And now what I am doing is like I am putting a color with respect to how the clustering has been done. So the plot as well as how the clustering has been done. So just I will increase this one. So in the figure you can see that this is one particular cluster which is very much defined from the other one, right? Because you also have seen the confusion matrix that for setosa it was like perfectly classified or clustered, okay. For the other two classes you can see in between some other observations are present. So the clustering has happened, but it's not, doesn't have a clear demarcation, okay. Now again if I just plot it with a title also, I'll be getting this one, okay. Now what I'll be doing is like I will just be giving the centers for the clusters. So k-means centers can be found out by just giving k-means.re $centers. So I have found the centers, and then I'll be putting it for all the different data which is present, and then I'll be plotting it once more. So now if you look at the data, you can see the center which is present. So for the black color points, the center is here. For the red color cluster, here is the center, and for the green color, the center is here. Now what you can do is, if you want to visualize the clusters again in this particular plot, just I will give k-means.re $cluster, and I'll be doing a cluster plot. If I do this particular thing, these are all like different ways by which you can personalize your particular graph. So if I do that, and if you just I zoom it here, so this is like a cluster plot. Okay, so how many observations are there, and this is like scale data. Okay, in the scale data, how many observations are there and how has the clusters been formed. So now here 3 clusters have been formed, right? Because we had given it to form like 3 clusters. Now again the same set of steps. If I had given k-means like centers equal to 4, this would have been a different value. Okay, so just I'll go to this particular section, and I am giving like centers equal to 4, and the same number of steps I'll be doing. Okay, k-means now have been formed with respect to the number of clusters as 4. So again you can see this particular data which is coming. So just I will just go to the confusion matrix again. Now you can see, so this is actually just for observation only. I have given the cluster as 4. Okay, so actually it's wrong because there are only 3 classes, we know that, but since it's an unsupervised algorithm, okay, and we had given it to be divided as 4 clusters, that's why it's coming in this way. But you can see most of the things are misclassified, so that's not required. And again we'll just do all the plotting that was done earlier with respect. So I'll just go to the last point. Okay, so here right now if you see with 4 clusters, you can see this particular thing again is taken as 1 cluster only. Then again we have blue, black and red. Okay, so cluster center, I haven't changed the color for that, that's why it's again coming as black only, but it means that it's a cluster center for this particular blue sets of point. Okay, now if I do a cluster plot, now the cluster plot will look like this. So here most of the other points, all other clusters are actually merged here. Okay, so this is with respect to the clustering algorithms for iris dataset. Okay, now just for more reference, you can go check this link which I have given here. Okay, now what I'll do is like just I will go through how to see different kinds of algorithms, because in your lecture class we have seen linear regression, logistic regression, k-means clustering and KNN algorithm, right? So just I'll be going with other different classification algorithms. First we'll be looking at decision tree. Okay, so just if you want to go through that, I'll just open this link. Okay, so these links will be shared to you, and so I'll be putting this particular link. So decision tree, so this you can also go through that. Okay, so all the things needed I have given. So decision tree will look like this. Okay, you'll be getting like a difference in a particular score. So in this particular data set there is a score which is given. Okay, so anyway we'll be going to solve with that itself right now. So for this particular thing we required all these different packages: dataset, CA tools, party, DP, LYR, and this one. Okay, so all these things I have already loaded, so I'll be taking this. Okay, and from this, in the datasets package there is reading skills data. Okay, data of reading skills. Okay, so reading skills, if you see, this is the particular data. This you have also seen, I think. So native speaker, whether that person is a native speaker or not, age, shoe size, and score. This is the data set which is given. All right, and in this one, just we have seen the data reading skills, and if I put head of the reading skills, it means the first 6 observations for the reading skill data. Now what I'll be doing is that I'll be doing a splitting of the data. This we have seen, right? Splitting as training and as well as testing sets, right? So I have the sample with me right now. I'll be splitting the data reading skills. So sample data I'll be putting in the split ratio 0.8. that means that 80% training and 20% testing. Then train data I am giving subset of reading skills with sample data equal to true. Okay, so sample data right now here looks like either true or false. Okay, so wherever true is coming, that will be changed as our training data, and wherever false comes, it will be given as our test data. So train data I am giving, and test data also I am giving. Okay, so yeah, so for having a decision tree model, okay, you can use a C tree function. So whatever arguments are included there are given: formula, data of list, and subset equal to. All these things, different things are present. Okay, later if you want to see that, you can go through the documentation. So model C tree, I am having native speaker as the thing which is to be classified. Okay, so yes or no, whether the person is a native speaker or not. So then I am putting the train data in that. Okay, so if I plot the model, okay, here plotting is also available. Okay, just I will increase the size and I will plot again. Sorry. So there is some errors coming here, just wait a moment. So this is the plot. So our end objective is to find whether the speaker is a native speaker or not, right? So you can see first division is done with respect to the score. Okay, so if the score value is less than or greater than a particular 31.086, it has given us 2 particular divisions, and then that itself again we are looking at score, and after this particular level the next level starts with considering whether the age of that particular person with this particular score, okay, is equal to 6 or greater than 6. Okay, so like that the tree progresses. Okay, so this is how the decision tree has been made. Okay, and testing the people who are native speakers and the who are not can be done with the predict function, because this predict function itself has been used in linear regression earlier. Okay, if you remember, or if you can refer to the previous classes, predict itself is used to find out the answer for a new observation. So predict underscore model, I'll be giving predict of model, which is right now our tree model, and I am giving it to test data. Now if I do this, okay, and if I am plotting, so I've predicted the model, I've kept it in predict model, and now what I'll be doing is like I'll be having or seeing a confusion matrix. So for the confusion matrix, I should have the test data $native speaker, which will give you the original target class of the test data, and predict model will give you the predicted class. Okay, so if I run that particular table of test data native speaker, okay, and now if I display that particular confusion matrix, you can see that in the prediction the true negative is 28, meaning like in the real model, if native speaker was no and prediction was no, came for 28 observations. For 3 observations, the native speaker was native speaker was labeled as no, but the classification had given them as yes. Okay, so it can be given of cases where there it is a false positive. Okay, so in the next one, the prediction is no, but the original case is yes. 0 observations have come in that, so that's okay. Now the true positive, which means that the particular observations are native speakers, as well as the model has predicted them as yes, there are 19. Okay, so all the other operations or metrics that we had looked in logistic regression, because right now this is a classification model, right? So all the metrics that we had seen in logistic regression, like accuracy, specificity, sensitivity, positive predictive value, negative predictive value, all these things can be obtained here too. Okay, because we have the original target class, we have the predicted model, and we have drawn the confusion matrix. So if you are getting a particular example or figure like this in your exam, and you are asked to find out the sensitivity or specificity, that is you'll be able to find that, right? So just for an example, if I want to find out the accuracy, so accuracy is like finding out the correct predictions by the total number of predictions, right? So in this particular case, it is like true negative, which is like correct prediction, the label no and predicted no, and labeled yes and predicted yes. So 28 plus 19 by 28 plus 19 plus 3 will be the total number of observations. So the same way I have just given here, I have given like diagonal of matrix, a diagonal of this confusion matrix, and the sum of the diagonal elements of the confusion matrix will be given by this particular statement, divided by sum of the elements of the matrix can be given by this particular statement. So if I run this one, you can find the accuracy as 0.94, which means that this particular decision tree model that we have constructed is 94% accurate. Okay, so all the other things which were seen in logistic regression can be done here. Okay, so this is how decision tree classification works in RStudio. Okay, I just have the classification with respect to SVM also, support vector machine also. So for support vector machines, actually theory we had gone through in our earlier classes itself. It is based on finding the hyperplane. Okay, so that also just I will go through in this last class. So here this is like, if you have, I hope you can see this window. So here you can see that there are a set of observations. In this observations there are, like you can see that there is sun shaped values and star shaped values are there. So you can draw any particular plane, like you have heard it as hyperplane. So any particular hyperplanes can be drawn which can separate these two particular points. Okay, in support vector classifier here right now, okay, because we are trying to split it into two different classes, right? So if you are using support vector classifiers, the objective is like to find a line or a support vector. Questions from this algorithm will not come, Vaishali. It's just for your information. It's not there. Yeah. So it's like, if you have a particular vector drawn, our objective is like to get certain support vectors which can find the maximized margin hyperplane. Okay, so here you can see that these are lying at the end of the margin of this particular hyperplane. Okay, so these are the support vectors. So actual theory behind the support vector machine or support vector classifier is to find a hyperplane which will maximize the margin. Okay, and in the subsequent figures it's shown like another figure is there, like where the support vector machine could run into in a real world problem. So looking at this particular data, you can see here these two shapes are like in a way where we can't draw a single line to separate the 2 points, right? So in this particular case, sometimes if you use the particular technique known as kernel technique, okay, that means that if you use a different kernel, so actually first you'd be starting with a linear kernel, but if you are doing some non-linear kernels, you can, for this particular example, it is like you are increasing the dimension. Right now this particular figure, it's like a 2D plot, right? So in this 2D plot you won't be able to draw any hyperplane, but just see that if I have these two axes and I have an extra axis which is added, for example an Z axis is added, okay, then you can have a plane in that particular axis which separate the 2 points. So sometimes you might be having different kernel techniques also to manipulate this data, which can be used to linearly separate the data. So that is also available. So just how to implement that in RStudio, I have just given here. You can just go through this site to learn more about it. Okay, so for this also I have certain necessary packages, okay, so that I'll be loading. So in this particular thing, caret was already seen, okay, in earlier lectures. So it's like classification and regression trees package. Okay, now ggplot, galley and this one are used for visualizations. Okay, so all these different packages, you can search for the packages. So for this particular example I'll be using another data set. Okay, so this is like a PIMA Indian diabetes data set. So this data set, if you want to download the data set, you can use this particular link. Okay, just I will copy and show that to you. So you can go to Kaggle and you can download the data set. Okay, so anyway I'll be using this data set right now. So I have already downloaded it and I am using read.csv because it's a CSV file. So if I do a files.choose, I have the diabetes data right now. So anyway, I'll clear the earlier plots and the environments also. You can do it with the help of a command, or you can just use the brush icon, right? So just I had cleared the environment. Okay, so yeah, I have loaded the data set. So this is the data set right now. Okay, if you go to the data, okay, so here right now you can see how the data is. So actually I hope you can see the data, okay, because yeah, so it's like these are the data set description also is given here. You can go through this data. If you want to see all the columns, you can select that. Okay, anyway, I have downloaded that data and you can see that here right now: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, predictive function, age, and outcome. Okay, so this is the data set. So outcome shows whether you are diabetic or not. So with SVM I have given so in this particular data set, actually there are some data pre-processing operations to be done. So first we will be checking whether there are any null values in our data set. So sum.isNA of df will show you. Okay, maximization is required for this screen, or is it required for the Google Chrome window? Is this okay now? Okay, so just you can see, those who are doing it with me right now, you can just type PIMA Indian diabetes data set. Okay, so if you just type that data set, actually you might be getting UCI machine learning repository or the Kaggle dataset. Okay, this also I can increase. So just go to the first option, which might be usually displayed for you. Okay, so you can go there and it will come to this page. Okay, so the data card will show you the data which is available in that particular data set. Okay, and the initial observations which can be seen, that also displayed in this one, how the distribution is done. I mean the operations that we have done, right? How the distribution, the pair plots that we have drawn. Likewise, plots are present here. Okay, to see how the data is distributed. And if you want to see, you can select the number of columns to be observed. If you want to download the data, you can use this particular option. Okay, so after doing that, you can come back to the RStudio and you can read the file from where you have downloaded it. Okay, then the first thing is to find out whether there are any null values in your data set. So sum of is.na of df will give you whether there are null values. So when I have run that one, I got the answer as 0, so there are no null values. Now to see the dimensions of the data set, you can just put dim of df. This also we had seen earlier. So you have got 768 observations. So I think for all the data sets that we have seen in this course, this might be the biggest one. Okay, so but this is actually a small data set only, the ones which we'll look in the normal everyday scenario. The data set number usually will be higher. Okay, so this is the dimension right now. There are 9 columns and 768 entries. Then if we want to see the class. Okay, I am doing the s apply. Okay, so here you can see for pregnancies how much is the data. Okay, so when I did an s apply for the data frame with respect to the class, yeah, this is observed. And if I do a summary of df like what we have seen earlier, all the data, their minimum value, first quartile, median, mean, third quartile and maximum value will be shown. I think this was discussed earlier also. Okay, so this is the summary. Then what I'll be doing is, like, since we will be looking for doing a plot like this, first we'll be plotting how the different values are looking like. So first I'll be using the ggplot package. Okay, and in this itself the data I'll be using is df, and the AES function will give you what is the parameter that needs to be given, okay, or which needs to be plotted. So first I'll be plotting for pregnancies, and then I'll be drawing a histogram like we have seen in the data card in Kaggle dataset, and I'll be filling the color with red and blue. Okay, and I'll be doing a density plot. So I've stored it in A actually. Okay, now for the same 9 set of features I'll be doing the same thing. All right, so for B I'll be doing for glucose values, then blood pressure I'm storing in C, skin thickness in D, and insulin in E, BMI in F, pedigree function in G, and age in H. Now what, so all these things I have stored right here right now, right? Okay, I hope you can see that. So just I'll be increasing the plot size, okay, because we'll be plotting this right now. So I have put gg arrange. Okay, so this will arrange all the plots that we have stored right now. So A has the first one which has pregnancies, B has glucose values, C is blood pressure. So likewise everything is given, plus I'll be removing certain values, and then I'll be putting labels also, and then I'm giving like number of columns equal to 3 and number of rows equal to 3. That means that your whole plot will be having, anyway you are having 9 columns, right? So the 9 sets of data or the 9 columns will be split like 3 rows and 3 columns. Like that the plots will be, can be observed. So if I run this one, so you can see the distribution. So it's like a density plot is drawn, okay, for A, which denotes the pregnancies, right? So this is the plot that you will be getting. Now from here you can see how the data is distributed. For example, pregnancies is having a very skewed data, then glucose also is skewed, okay, but it's closer also to a normal distribution. Then blood pressure skewed, as well as outliers are there, skin thickness and insulin, BMI. So all these observations you can draw from this particular plot. Now if you want to see what are the different like, just if I do this particular thing, okay, so they are asking it like, so just I'll be plotting a GG plot, okay, data equal to df I am giving, and the aesthetic is with respect to outcome I am going to draw. So I got a warning like this one, fails to infer the correct grouping structure. It has failed to infer the correct grouping structure, and they are asking us, whether the error was caused because the specified group aesthetic, or we have failed to convert a numerical variable into a factor. Okay, so that is the case right now. Here we haven't converted the outcome to a factor. So what I'll be doing is like, so just our data which is stored in df, we'll look at the data, okay, how it is. So pregnancy is glucose like this, and this is our outcome. So outcome you can see here. So whenever we have been considering classification algorithms, we have either made, when we read the data, we have given like as factors, we have given a line. Otherwise, in other cases, the data was already loaded as, the outcome was already loaded as a factor. But in this particular case, if you hover over this particular column name, it's given as numeric with range 0 to 1. That means that it is not accepting as a numerical, as a factor column, it's accepting it as a numerical column, which means that you can't have a classification algorithm applied to this particular data set because your outcome is not categorical. Okay, so for converting it to a categorical, I am just putting here df dollar outcome. Okay, factor of I am giving to make it in the form of factors. Okay, I am changing the df dollar outcome, and levels I am giving like 0 or 1 because only two levels are there, either the subject is diabetic or non-diabetic. Okay, then I am giving labels negative as well as positive. The labels for those classes as negative and positive. So I am going to change this particular outcome column. Okay, so df dollar outcome I have done like this one, and now if we see, you can see that I have changed the outcome like a factor with two levels, and labels are either positive or negative. So we have changed that. Now again, if we are doing it, okay, and just a subset we are selecting. Now if we are doing the gg plot, maybe you can see the, so earlier we didn't get it because, and the warning they have raised like you have forgotten to classify it as factors. Now since we have made it as factors, this plot gg plot have been constructed in this way. Okay, so it's like negative or positive. Negative means the patient or the subject doesn't have diabetes, and positive means that the patient has diabetes. Okay, now so we have done that particular thing. Now what we'll be doing is like, we will be doing another plot. So in this particular thing we are looking at different visualizations. So earlier in the gg plot we have looked at, this is a bar plot, and before that we have looked at a density plot. Okay, now what we are going to do is we will be looking at a box plot. So the same things will be getting, you might be remembering about the melt functions and all, right? So the same thing I'll be using for a box plot. So if I see a box plot here, okay, you can see just I have drawn for the different variables. Okay, these things you can have certain personalizations done so that the you can rotate these values to see the values nicely, labels nicely. So here you can see the pregnancies are there, then the glucose values, and for insulin you can see so many outliers are present. So box plot will help you to see the distribution, right? Okay, so this is box plot. Okay, so what we'll be doing is like, so another thing that we can do is to find the correlation. So correlation you can use core plot, and df you can mention, and the columns 1 to 5. So if I do the column plot, correlation plot, okay, just wait a moment. Yeah, so I'll just do that once more. Okay, the errors are coming like this. Wait a moment, that might not be the problem. I'll be putting the train df as well as the test df. So I'm putting a data, this is another way for splitting the data. Okay, so it's like create data partition df outcome. Okay, and now I am putting the test df and train df. Likewise, like earlier, we have to set the seed, and then I am putting like train control method equal to cross validation number 10 and class probabilities equal to true. Okay, now we'll be using the metric accuracy to find out which classification, how much classification to be done, what classification to be done. Then I'll be training the model, and after that, just wait a moment, let it train. So I think it has trained, and for the model summary I have taken model like this. So you can see here we have made a model support vector machine with radial basis function kernel. Okay, these kernels, you can look the file that I'll be sharing. Okay, so linear kernel is the basic one, but if you have non-linear data, you have to go with other types of kernels. And there are two classes, negative or positive. So we have values like this. Okay, so there are different set of values for support vector machine which can be seen later. Okay, so anyway, I'll be plotting the model. Okay, and then just the same things, predicting as well as the confusion matrix. So this can be seen later when you go through that particular model. Okay, so here if I use the instead of the table function, if I use confusion matrix, then I'll be getting the whole set of data. Okay, it's like I have the confusion matrix here, and directly I can see the accuracy of the classification done, set 75.65% only. Okay, and the p-value, this kappa value and all is specific to this particular support vector machine. Then sensitivity, specificity, positive predictive value, negative predictive value, all these things you have seen earlier itself. Okay, so this is how SVM can be implemented. Okay, now I think I have gone through most of the things to be done in this particular weeks. So if anyone has any other questions, you can ask me. Regarding the assignment which was shared. Or any other questions? So I hope everyone is clear with the questions that were shared, right? So I will share this particular assignment PPT as well as the programs that I've shared today with you, the newly shared ones as well as the different models, extra models. Okay, So I think your exams will be coming, maybe, I mean, it'll be coming shortly, right? So learn well. And if there are any doubts, you can use the discussion forums, and I'll also be going through that and will be answering the question. So anyway, everyone, learn well for your exams. Okay then. Thank you, everyone. Yeah, yes. Okay. So yeah, anyone has any doubt other in other sections? Okay, yeah, fine. So yes. Course material, that depends. I'm not sure about that. Okay, Vaishali, it might be there till the next course also. Okay then. Okay then, everyone. Study well for your exams and have a nice rest of the day. Thank you.